The goal that everyone hopes for with exoplanet research is the detection of Earth-like planets, as Earth-like as possible in every way. We're not there yet, but we're getting very close. With the Doppler method, planets within a factor of 2 of the mass of the Earth have been discovered. And Kepler has found Earth-size or even smaller planets, although we don't know the masses of all of them. We're clearly homing in on worlds like our own. A computer simulation of the formation of terrestrial planets shows how this may work. In some simulations, it's possible to follow the water or see how the planetesimals that accrete to form planets harbor and move their volatile materials around the solar system. The color coding here is such that blue represents icier or more water-rich rocks, and red indicates drier or more baked rocks closer to the planet. The ellipticity represents the deviations from circularity, which is the means by which these planetesimals collide and then accrete to form rocky planets. The entire process takes just a few tens of millions of years, and in this case, several rocky planets are formed. Although in this case the planets are very similar to the inner planets of our solar system, when these simulations are done dozens or hundreds of times, various architectures are found. However, it is typical that Earth or similar to Earth mass planets are formed, and rare that none are formed. After the discovery of hot Jupiters, people wondered whether it was possible for such systems to have Earth-like planets, and speculated that it couldn't be. The presence of a giant planet so close in, and the fact that it migrated from further out, would cause chaos in the inner solar system. But this second simulation shows that that may not be as simple as that, because it turns out that when giant planets migrate into their parking orbits, they do so very quickly, within 1 million years after formation. Subsequent to the migration, there's plenty of material left over for the formation of terrestrial planets in normal orbits. In other words, we should not rule out the presence of Earths or habitable planets in the hot Jupiter systems found so far. The sum of these simulations gives a sense of what might be out there, what we can expect to find in terms of water worlds. Perhaps the surprising result is that systems like the Earth, with the same inventory of water as in the entire Earth's oceans, are not unusual. Some terrestrial worlds are formed with less water, but many are formed with 10 or 100 times the water of the Earth. It seems like Earth-like planets will not be rare. And typically, the number in any given system is between 1 and 6. Let's see how detecting Earths compares to detecting Jupiters using the primary methods of detection. Relative to Jupiter, the Earth is 5 times further away, 10 times smaller, and 1,000 times less massive. That's all the information you need to see how hard it will be to detect. With the Doppler method, the Earth is 5 times closer, but 1,000 times less massive, so it exerts a 200 times less lever arm in the reflex motion. That's very small. The reflex motion caused by the Earth on the Sun is only 9 centimeters a second. That is at the level or below the level of detectability by the Doppler method. Researchers hope they may be able to reach this, but it's not clear that it's possible. For the eclipse method, the Earth is 10 times smaller, so its area is 100 times less than Jupiter. So a 1% Jupiter eclipse turns into a 0.01% Earth eclipse. 1 part in 10,000 sounds small, but with the stability of the space environment, it's easily detectable. Direct detection of Earths by imaging is extremely challenging. The Earth has 100 times less area, but is 5 times closer. So in the inverse square law, a factor of 25 is brought back, making the Earth reflect only 4 times less light. However, the Earth is 5 times closer, so its separation in projected angle from the star is 5 times less. This is extremely difficult unless the star can be exquisitely subtracted at a level of a few parts per 100 million. If we find Earth clones, will they be exactly like the Earth? Almost certainly not. They will differ in many ways, some subtle, some profound. And if we do find an Earth clone, unfortunately it won't relieve us of the obligation of taking care of our planet. It's so expensive to go to a nearby Earth, even if it were within tens of light years of this planet, that we'll never go there. We'll never be able to send people there, even within the next century. The technology is too difficult to travel these large distances. It's by far the best strategy for us to take care of Earth 1.0. Excitingly, just in the last few years, an Earth-like planet has been found around Alpha Centauri b, essentially the nearest star at a distance of 4.4 light years. This Earth-like planet is not in a habitable orbit. It's extremely hot on a tight orbit of its star. However, that does not preclude there being Earth-like planets in slower orbits further out. In fact, the Alpha and Proxima Centauri system offers a double chance of detecting Earth-like planets. The two primary stars are both Sun-like, or nearly Sun-like, and they're far enough apart that terrestrial planets could happily orbit without being disrupted in the binary star system. As we've seen, Doppler detection of Earths is at the limit of the technique, but with the Alpha Centauri system, there's tons of light to work with. Essentially, by persistence and observing every few days for several years, it should be possible to get down not only to Earth mass, but Mars mass planets in each of the two stars, giving a double chance of finding an Earth clone a few light years away. A holy grail of exoplanet research is the detection of Earth clones. The Doppler method has got us close, within a factor of 2 of the mass of the Earth, but it may reach its fundamental limit around that mass, because the size of the Doppler effect rivals the natural turbulent motions in the star, producing a noise source that cannot be overcome. The transit or eclipse method can comfortably detect Earth mass or even smaller planets, and has already found some Earth clones, including one close to the Sun, Proxima Centauri system.